So as we start to move forward, as you can see, uh, it's not that we're done with the alkanes, because we're not. Because you will go through certain types of reactions where you will start talking about alkanes again. But when you see these two organic families, how do we know we're dealing with that of an alkene and an alkyne? Okay. Now, these are going to be what I want to say more common than what you think. The reason I say that is not everyone's going to look at ethine and think, why would you ever deal with a gas known as ethine? Well, no one would probably ever think that. But when you go by its common name, which is acetylene, you might think, oh yeah, that makes a little more sense. And even in your case, you may have never dealt with acetylene, but you may have heard of it. Do you perhaps know what acetylene is? You can use it, but it's not for burning and internal combustion. Nope. When we're talking about acetylene, you combine that with another gas, oxygen, and you have a cutting torch. Okay? So what happens, the oxygen acetylene torch. So when you strike that, you have two tanks, and the smaller one, I believe, is the acetylene, and then the larger one's the oxygen. You have them probably on some sort of cart, and you got them chained on there because you don't want them to tip over. But when you actually light that torch, you're probably igniting the acetylene, okay? And then you turn the other valve on, and then there's a handle where you press your thumb, okay? And then what happens is once you got that lit, that acetylene just doesn't burn very hot. But once you start pouring some oxygen on there, now you're getting somewhere from probably 400 some degrees with just the acetylene to over 2,000 when you start mixing that oxygen. We know that's would be the case when you think of something called the Bessemer process. Have you ever heard of Bessemer? And if you'd ever seen, I think you talk about in history where it was called The Men Who Built America. When you think Andrew Carnegie, you ever heard of him? Okay, Carnegie was a man who built the steel mills in Pittsburgh, and one of the aspects behind that is the story goes that he had to build a bridge, which would be highly tough to do to create that much steel, but over in England, it was Henry Bessemer who created a process to mass produce this steel because what would blacksmiths do? They're burning some coal, and then they really need to get that a lot hotter to either make horseshoes or different types of aspects back in the 1800s. What might they do? Had something to do. They're pulling on a handle. Yeah, it's called a bellows. Okay, and what that bellows does is you're putting more oxygen in there. So it's the same process as whether the Bessemer process, the blacksmith, excuse me, or the oxygen acetylene torch. You start mixing them two gases, you're going to get a lot of heat. Okay, so no one would really think of ethine in that process, but acetylene maybe. So no one would ever think of ethene, but you really don't know it as ethene, but you might know it as polyethylene, which is more commonly known as this, plastics. And throughout the course of a person's day, how much plastic you come in contact with is probably mind-blowing. Of course, there's a downside to that as well. I think we're getting better at creating corn-based plastic because that has a better rate of doing what in the landfill? Decomposing, yeah, because if it's organically made, it's probably going to decompose organically made. Okay, it's when we make this polystyrene, polyethylene, you're not creating that from a plant-based material, so therefore it's not going to decompose as fast. But anyway, excuse me. What's going to happen is in this chapter, we're going to start setting the stage for a lot more of the different types of reactions. All that we've done so far is reacted halogens. These get to be perhaps a little more complex when we start reacting them with the alkenes because you're responsible for more than one product. But that won't mean anything until we get to that point. Okay, so as we move forward, okay, they're both, as you can see, we got a double bond, a triple bond, and these are also insoluble in water. And just like when we think of the alkanes, of course, natural gas or methane is going to be in a gas form, ethane, and propane. But for anyone who's ever had to light a grill, what's true about butane then? You got to, yeah. But what's true about the butane though? I wouldn't call them torches, because my point is what state is that butane in? No, it's a liquid. Or you could say, no, it's South Dakota. What state is it in? Ah, ha, 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 ha. We're just seeing if Mr. Hoth is going to watch this, see if he points that out. So it's kind of, it'll be his pop quiz. Yeah. All right. So as you can see, they're named similar to the alkanes. The prefixes are going to be just the same. You're always going to find the parent chain, but the difference is you need to name where that double bond is located. Okay? That's the main difference between that of the alkanes and alkenes. Okay? So again, when we see these are non-polar, okay, that's one of the aspects when you start dumping sugar or especially salt in water, notice that dissolves because water is a polar compound. These, as you can see, are non-polar, just like oils, fats. Those are all non-polar. So, and gasoline, diesel, those are non-polar because they just do not dissolve in water. Why? Yeah. Why is that? Mm-hmm. A lot of them. Yeah. Yep. Yep. That's true. Anyway. And also in this case, as you can see, there's going to be more isomers when it comes to that of the um, alkenes as opposed to the alkanes. Yes, that is correct. Yep. When you look at these, you're seeing there's going to be more uh, more isomers than what there are for the alkanes. So I want to see. So we'll come back to this. Let me just. Yeah. All right. So does everyone have this information that wants it? Okay. Because one of the things I need to get this printed off. Okay. And this is something that you'll probably take with you to well, one of you will. And just like I like to say, with even with that of the periodic table, students come in and ask, "Do we need to memorize that?" I think that's slowly starting to fade away. I think you would agree. You might have that parts of that memorized now, just because you've utilized it a lot last year. Okay. And certain characteristics like that of calcium, strontium, beryllium, magnesium, when you look at them, they're in column 2. The most important thing you should know about them is what? Yes. You could say column 7, the halogens. You could say the same, something very similar. Well, right, but what does that mean? In other words, halogens are doing something totally opposite than the alkaline earth metals. Right. Right. So whatever column it falls into gives you the valence electrons. Yeah, that's the most important characteristic of that, how many outer energy level electrons it has, or valence. Okay, hopefully good ones. A. Afabu. Yeah, that wasn't supposed to pop up. Darn it. Okay. Oh, this is what I was looking for, this guy. Okay, so this doesn't mean anything to you right now, but hopefully it's kind of a pathway on all the different reactions that we go through. So I'm just going to try and print one. That's not what I wanted. Okay, let's see here. Okay, shoot, I'm having trouble printing, so I will work on that for just a moment, and we'll catch up to you next time.